Today we're going to look at what is called direct variation. So in order to look at direct variation, first of all, you need to be familiar with something that we call the slope-intercept form of a linear equation. Y equals mx plus b. Now when you have an equation written this way, first of all you have ordered pairs that consist of an x and a y. So here's the x and here's the y. That would be the numbers for an ordered pair. That leaves two more numbers. The m stands for the slope of a line, and the b stands for the y-intercept. Now what we're going to do with direct variation is we're going to look at an equation like this, except on each one of them, the y-intercept is going to be 0. So this part of the equation is not going to be there. So we're going to be looking at an ordered pair with an x and a y, and we're going to be looking at the slope. Now, because the slope today is going to be constant, that means it's going to be a linear equation, and the slope between each of the ordered pairs is going to be the same. We're just going to rename this m into k, which means a constant. It means a constant slope, a slope that stays the same. So if you look up here, here is the equation for slope-intercept form. And what we're going to do is, since the y-intercept is 0, this is not going to be there, and we're just going to replace that with a k. It stands for the same thing. It's the slope. It just means that the slope is going to be constant. That we call that a constant of variation. So let's just look at some equations here and see if they would be an example of direct variation. Remember, y equals mx plus b. So we don't want a y-intercept, which would be right here. Notice it's not there, so that means that's a plus 0, so that's good. And there is a slope, so this is an example of direct variation. It's an equation with a y-intercept of 0 with a constant slope. If we look at the next one, if we were to rewrite this in slope-intercept form, this term would have to move from one side to the other, so we would have to add 3x to both sides. When we do that, we still have 5y on the left side. We have a positive 3x on the other side, and a 0. Notice here, we have a 0 again for the y-intercept, and now we would divide both sides by 5, and y equals 3/5 x. So we have direct variation here. We have 0 as the y-intercept, and we have a slope. On the next one, let's see if it would be an example of direct variation. If we were to put this in slope-intercept form, we want the y on the left side, we want the x term on the right side, so we have to subtract 2x on both sides. When you do that, you get y equals negative 2x plus 10. Notice right here, our y-intercept is 10. That is not 0, so that is not an example of direct variation. Now, this is a table. And when you have a table, the top row is always going to be the ordered pair for the x, and this is going to be the y. So if you look right here, we have an ordered pair of 1, 3. If you look right here, we have an ordered pair of 2, 6, ordered pair of 3, 9, and an ordered pair of 4, 12. So 4 ordered pairs represented in this table. Now, to find the slope, it's always the y on the top and the x on the bottom. So if you look here, the y is 3 and the x was 1. So we just put the y's on the top and the x on the bottom, where it's y divided by x, and that's going to give us our slope. So that's 3 divided by 1, which is 3. What we're going to do here is see if it would be the same all the way throughout it. Here we have 6 divided by 2, because you put the y on the top, and 6 divided by 2 is 3. The next one, we have 9 divided by 3, which is also 3. And we have 12 divided by 4, which is also 3. So if we were to graph these 4 ordered pairs, it would show an example of direct variation. And let's just take a quick look here. If this were my graph, and I were to graph these 4 order pairs, our first order pair would be 1, 3, so 1, 3. Our second one would be 2, 3, 4, 6. Our third one would be 3, 7, 8, 9. 9, and so forth. And what they do is they create a straight line, and it passes the y-intercept at 0. And the slope was constant. The constant slope was up 3 over 1, up 3 over 1. So we call that constant of proportionality, which just means the slope stays the same. And we rewrite the equation. We put the slope right here, which was 3. We put that in front of the x. That's where the slope goes. And so that's how you write the equation. There it is right there. In our next example, let's see if this would be an example of direct variation. Okay, again, the x values are on top, and these are the y. So this is the order pair 1, 6, the order pair 2, 14, 3, 22, and 4, 30. But in order to find the slope, you have to put the y and divide it by the x. So you flip it. So this would be 6 divided by 1, which is 6. Then you have 14 divided by 2, which is 7. Now you can stop right there. This is not going to be a straight line because the slope was not the same between each of the order pairs. And if I keep going, you'll see that it's not the same for any of them. So if you graph it, it would not be a straight line. You would have a slope of 6, then you have a slope of 7, and then it would be different slopes, which makes each line get steeper and steeper. Not a y-intercept of 0 either. Not direct variation. Okay, so again, we have the order pair of 1, 8, the order pair of 2, 16, 3, 24, 4, 32. But to find the slope, we take the y and we divide by the x, so that would be 8 divided by 1, 16 divided by 2, 24 divided by 3, 32 divided by 4. And when you do all of those, you will see that they're all the same. That means this is an example of direct variation. So all we do is we take the slope, y equals, and we're going to put it right here in front of the x. So it would be y equals 8x. That's our equation. So once you do that division right there, you know what number. If it's the same, since this number right here was the same, to write the equation, we just put it right here in front of x. That's how we write the equation. Okay, so let's look at another example. If we were to graph this, you would see that it would make a straight line. Here is 1, 8. Here is 2, 16. Here is 3, 24. Here is 4, 32. And you will see that it does cross the y-axis at 0. It has to be at 0 right there where it crosses the y-axis. So that is direct variation. So k is both the constant of variation and the rate of change. It's also called the slope. The only difference between rate of change, which we did yesterday, and direct variation is that direct variation is always going to have a y-intercept of 0. That means it's always going to start at 0, 0. Look at this next graph, and I'll show you how that works. In this first one, notice right here, the y starts at 3. It does not start down here at 0. So this is an example of rate of change. This one over here starts at 0. So this one is direct variation, and it is a straight line. You must have a straight line, and it must start at 0. So again, let's see if this would work. Here we would have 5 divided by 2, and 10 divided by 4, 15 divided by 6, and 20 divided by 8. You always take the y and divide by the x. If we do that, you'll see that each one of those would be 2.5. 5 divided by 2 is 2.5. This would be 2.5. We have the same slope, same constant change there. Determine whether the pattern forms a proportion. So admission to an amusement park is $4 plus $1.50 per ride. So if you rode one ride, how much would that cost you? Well, first of all, you have to pay to get in, which is $4. You rode one ride, so if you add those together, that would be $5.50 for one ride. Now, if you rode 2 rides, you would still have the $4 for admission, but 2 rides would be $3. So when we go $4 plus $3, that would be $7. If you ride 3 rides, you add another $1.50. That'd be $4.50 for rides plus $4 for entrance, so that's $8.50. And for 4 rides, that would be $6 plus the $4 entrance, so that would be 10. So would this be an example of direct variation? Well, let's look here. 550 divided by 1 is 550. $7 divided by 2 is 350. So you can already tell right here that it is not. If you were to graph this, you would start at 4. 1, 2, 3, 4, because that's the cost of admission. And then each time, for each ride, it would go up $1.50. So notice here, it does not be at the 0, 0. The y-intercept would be 4. So that is not direct variation. Now, this is what you're going to see on your paper today. It sounds kind of confusing, but once you know what to do, it's very simple. It says write an equation expressing direct variation where y varies directly as x. When it says that, it means you're going to put the y on the top, you're going to put the x on the bottom, and you're going to simplify it. That's all you have to do. And once you simplify, you're going to put it right here in front of the x for the constant. So if y is 20, you put the 20 on the top, you put the x on the bottom. 20 divided by 4 is 5, so I know that my slope is 5. It goes right here where the k is. So I simply write y equals 5x. You're always going to have the y here, the x here. Here you're just plugging in whatever this number is. So that's just y equals 5x. So just take the y, put it on top, take the x, put it on the bottom, simplify, and then you can write your equation. Okay, here we have the same directions. Write an equation expressing direct variation when y varies directly as x. So here's the y, you put it on top. Here's the x, you put it on the bottom. And then when this one cannot be simplified, you don't want it into a mixed number. It has to either be a simplified improper fraction, but not a mixed number. And this one's already simplified, so simply put this in place of k right here, and we write our equation as y equals 23/9 x. See how I plugged it in right there? Just plug it in. Put the y on the top and the x on the bottom. So you put the y on the top, which is 35. You put the x on the bottom, which is 28. Both of these numbers are divisible by 7, so that would be 5/4 simplified, and I'm just going to plug it in right there. And when I do, that would just be y equals 5/4 x. So, just in review, when you get questions like this, just remember when they say the y varies directly as x, you're going to write the two numbers with the y on top, the x on the bottom, simplify it, and then when you write your equation, it's going to be y equals this k, this constant. This is where you put what you've figured out right here. It's the constant, and then you put x. So you just replace the number, put the number in front of the x, and you are good to go.